for Greek life for SMU. Whatever it is isn't true, by the way. Is that a quote? I guess someone posted it. If you don't get the house, you should.
Saw it on the internet.
You might as well be in
It's
school.
true.
I'm kidding. I'm literally the
I mean, who would go on the internet?
Except for store. I know Sam.
Fair enough. Fair enough.
Cool.
I just want the stat. The number.
All right. Huh.
Yeah, I think that's probably the reason why it's back anywhere from like.
Interesting.
Like I've heard 66%. I feel like it's the highest percentage.
That would be the day. Man.
All right, let's go ahead and get started. Welcome to Lecture 22 for CSE 5323 7323 Mobile Sensing, Learning, and Control. Today is going to be a little bit different in terms of lecture. I only have about 10 slides. We're going to get through them pretty quickly. The rest of the time, I'm going to sit down and pore over 2 demonstrations of the code on how to use both the scripts that I gave you online that are on Blackboard, and then I've got another example where I'm actually using a calibration protocol, and we'll go over what that looks like for the rest of the time. And then we'll talk about Wednesday. Okay, so this lecture is entitled Machine Learning as a Service. Okay, course logistics. A4 grades are not coming. They're up. So are A5 grades. I don't know why that's still on there like that. A6 is still due Thursday with the final project proposal, which is a 1-page upload as PDF, Word doc, whatever you want to do. Okay? Questions on that we can handle here? Question?
So do you have a specific template for proposal?
For the proposal?
Yeah.
Not really. At the beginning, I think, of lecture 19, I gave kind of an example where it was like a summary paragraph and then some example bullet points where the constraints would be made. That would be, I mean, if I were going to post something, it would be that. So take a look at that and kind of emulate it. It's going to be, I don't know, a half page. It might be a full page if you're really like throwing some screenshots or something. That might be nice. Yep.
So whatever we propose, can we change it, like details later on?
Whatever you propose, details, can you change it? Well, what the constraints that you propose are the constraints that I am going to be grading you against during the final project. So those can't change. Other things can, that are part of it. But once we lock down what the constraints are that your app is going to meet, and it'll take like a couple of iterations here. Well, I'll get back to you guys and say, hey, this is not, beef this up, and then resubmit, and then we'll keep chugging along. Okay. Once that's finalized, you have to meet those constraints.
Okay.
But they're self-imposed.
What if we maybe decided to change completely new project?
To a completely new project?
Yeah.
Don't do that.
Okay.
Propose something and do it. Because, I mean, like, right now, if you were to start today, that only, I don't know how many days, how many weeks we have until May 7th, which I think is the demo. Not a whole lot.
Okay, about 2 weeks.
2 weeks? More, I think like 3. 3 weeks? We got like 3 weeks before it's demo time, right? Wow. Yeah. I think there's some like 4 lectures left in class.
Okay.
All right? All right. That's kind of why I wanted A6 to be a first draft. But if it's not, that's fine. So the agenda for today, I'm going to give an extended example of assignment 6. I'm going to go through a lot of the code that I have. And maybe even before that, I'm going to talk a little bit about what I mean by deployment and deployment of a machine learning algorithm in this class and how you might use that later on. Okay, so how are you guys feeling about data? How are you guys feeling about the data that you're collecting for A6? Don't know. No one knows. Okay, well, when you get far enough into it that you're worried about your data and the data that you're uploading for A6, this is a really, really good roadmap. I got this from the internet. This is by Andreas Mueller. And if you were in machine learning, you'd be like, wow, this is awesome, because he's really good. And he is. So essentially, he tried to put together a algorithm cheat sheet for how you do classification or how you do regression or how you do clustering based on the data that you have. And this is essentially an example that should be impossible because it's so application specific. But this roadmap, I think, is really, really good. I think you can probably get through 90% of machine learning issues by just following this. Right? So I wanted to have it in my slides. You can also find it online. But essentially, I won't go through the whole thing, but essentially you start here and you look at how many samples you have, what you're trying to predict, whether it be regression and what methods you might use depending on how much data you have. And then kind of other things that you might want to do, such as clustering, classification, and dimensionality reduction. The one big thing that I will say here is that if you have less than 100,000 samples and you're trying to do classification, that puts you over here, right? And the first thing that he has you try is this thing called linear SVC, right? So, okay, you have less than 100,000 samples. I'm guessing everyone in A6 is going to have less than 100,000 examples. I might be wrong, but I'm guessing you have less than 100,000 labeled examples. If that's the case, the first thing he says to try is linear SVC. What's that? What is a linear? You know. What? What is it?
Linear support vector machine.
It's a support vector machine classification, right? So it's a lot of stuff that we've already gone over. That's the first thing he says to try. It says not working, go over here. You got text data? Are you looking at text data? Yeah, go over to naive Bayes. No, go to a k-nearest neighbor classifier. Not working? Oh my gosh, go to SVC and ensemble classifiers. Go from linear SVC to SVC, what's the difference? When we're going from, let's say we get all the way down this path, it tells me to try SVC again. What's the difference?
A different kernel?
Yeah, it's a different kernel. Yeah, what do I mean by kernel? Somebody. Anybody. What's that? Wait, no. I want to hear it. What is it?
I made the joke of Linux versus Windows.
Linux versus Windows. Oh. Woo. So like a radial basis function versus a linear kernel, right? So when we were looking at that SVM example, it was the difference between a vector that cut your data in two like this versus something that clustered it with that little Gaussian look on it, right? So basically, the idea here is start really, really simple, linear support vector machine, then get progressively more complicated. Why? Because in the face of all the different problems in the world, the simplest solution is probably the right one, okay? Make it as simple as possible, but no simpler, okay? I'm just quoting Einstein now. All right? Why would I quote Einstein? Because he was a really down-to-earth person, as it turns out. Okay, assignment 6. You guys have seen this a lot now. So now let's talk about it really, really quickly before we do the demo for assignment 6. So you guys have a web server. What's the web server? Tornado. What is Tornado connected to? MongoDB. What is the data from MongoDB doing? We're just going to train a model, right? So there's a couple of different functionalities that you're going to want from your web server, right? So let's say you've got an iOS client, right? The app that you're building is fundamentally taking the user through a calibration protocol. Is that right? Do you guys know what I mean by that? Like we've got this, somehow we want to send labeled data up to this web server, right? That's just the calibration protocol, right? And then there's going to be like maybe a little test phase or something that the user can go through, right? So we have to be able to request a dataset ID, right? Why do we need a dataset ID? Sure, maybe it depends on your application. Maybe you don't need a dataset ID. Maybe you can just upload data and call it good, right? But in the code that I've given you, there's some functionality for requesting a new dataset ID, right? And it'll be like, oh, okay, here's a new dataset ID. Whenever you upload data, just tell me what dataset ID you have, and that way I know where to put it, okay? All right, so you're going to request a dataset ID, and it'll assign it back. The next thing is we're going to provide examples, right? That's the calibration protocol. So whatever you are classifying on, whatever you're doing, You're going to upload features and labeled data, right? And you're going to upload features and labeled data for that dataset ID that you have. Okay. How do you specify your dataset ID to the web server? How does it know? Because you tell it. How do you tell it? Yeah. No, you're right. You're exactly right. Yeah. Either way. Either way. Probably, I don't know. It probably makes more sense to have it inside of the URL or get example, unless you want it to be slightly more private, in which case it could be part of the post request. You can still do a post request with arguments in the same way that you would have get. You guys know that, right? Still good? You can still do queries on the URL. Okay. And then maybe your iPhone is going to then tell your web server to create a model, right? Does the iPhone have to tell your web server to create a model? Let's say you're just uploading a bunch of labeled data. Does the application need to tell the web server to create a model? Doesn't have to. Depends on your application. Maybe it makes a whole lot of sense to every night at midnight, we're going to create a new model based on all the new data that just came up. Or maybe it makes, maybe you want more accuracy on the app, and you're like, okay, give me a new model. I want this to be more accurate. Trains a new model and it starts working. You can test it out. Maybe that makes more sense. Okay, all of that is implemented right now on the web server. You can also request predictions, right? And it's the same exact format. I won't bore you with it. Okay, you upload the feature data and it gives you back a label, right? All right. Okay. Deployment. So deployment is a fancy word for essentially how are you going to implement your machine learning algorithm? Where is it going to reside? Where is it going to be running? Right? So the title of this lecture was called Machine Learning as a Service, right? So as a service, nothing is running locally on the phone, right? It's a service that's running in the cloud, right? So all of your features, all of that data collection is something you send up. And when you deploy it, it's just training a model and saving it inside your web server. And now whenever you have a prediction, it sends that back down. That's okay. That works, right? That's very easy to streamline across a bunch of, you don't even care what applications people are running, whether it's from Android, iOS, doesn't matter, right? Because you're running as a cloud service, right? The one thing you don't want to do is try to train something on a mobile device. Okay? It's really, this is a really powerful tool. It is really powerful. It's not quite that powerful yet. Okay? It's not going to be able to do a lot of the training that needs to be done. There's not enough memory, but there's probably enough CPU cycles. You could do it. I don't know why you would want to, though. Does that make sense? You may think of a reason why you would want to train up your model on the phone. It's maybe a little more secure. You don't have to send data across the channel. Maybe you're in a remote location. Like maybe you're in sub-Saharan Africa. And you are trying to create an application where you're taking medical images. Right? You do not have access to, say, a Wi-Fi network that's near you, and you need to train it on a local phone. That's absolutely a possibility. Are you guys going to run into that? Only if you're in research. You're probably not going to run into that in industry unless you work for a pharmaceutical company. Yeah? Okay. So, yeah, it doesn't make sense to train it on the phone. Does it make sense to have a prediction model on the phone, though? Yeah, I would argue prediction's no big deal on the mobile phone for a parametric model. What do I mean by that? You guys remember what parametric versus non-parametric was? So it's probably okay to run a trees classifier or a support vector machine on the phone. Because all you have to do is save the parameters of that model, right? So it's a support vector, so very minimal memory usage that you're doing on the phone. Or a tree, right? All you have to select is the different nodes and how you traverse through the tree, right? So that's a pretty easy classification. Would you run k-nearest neighbors on the phone for prediction? Why might you not do that? You might have tons of data that wouldn't fit on the phone, right? K-nearest neighbors requires that you have, most implementations require that you have all of the data from your data set, right? So maybe you have 150,000 examples. Those would need to be on a phone to be able to, because all of the hard work happens at prediction time, right? But it still makes, if you're going to deploy this machine learning model, it still makes sense if you have a parametric model to run it on the phone. So the basic idea behind deployment, and one that you'll see a lot more and more nowadays, is that you can train this anywhere, right? You train it in the cloud, but you might do local predictions on the phone. You might do it really, really quickly, right? And it doesn't require that you have this HTTP service running, right? But in order to do that, you're going to need a standard language for all of these model parameters, right? If you are going to run something on the phone, you need to be able to load up the model that you created, okay? And if you're training it in, I don't know, scikit-learn, it needs to be able to hook up with iOS because you're not going to run Python on an iPhone to do the prediction, right? So you need to be able to load up the parameters of that model, right? Or if you train it up in RapidMiner, right? And you export this model, you need to be able to load it on the phone. Okay, so the standard way to do that is to export all of the parameters for a machine learning algorithm. There is no standard, which there is a quasi-standard, okay, which we will talk about, but I'm not requiring anybody to implement. And that standard is an extension of XML, okay? And that standard is called the Predictive Model Markup Language, right, PMML. And if you go on to IBM DevelopWorks, you can actually get all of the standards that are there. And essentially, what this PMML does is it's derived from XML, so it's really easy to port over, right? And it defines all of the pre-processing that you do to your data, and it saves it, right? So any data that was posted up, it'll go and look in the XML file for how do I pre-process that, right? Am I gonna, take the features and divide them all by 5, right? Am I gonna take them and subtract some mean off that I've learned somewhere, right? Am I going to use principal components analysis? And what are the principal components that I'm going to project everything down onto? All of that would be defined in this pre-processing set. Then there's a way to essentially go through and look at classification, right? So for each different algorithm, inside of this PMML is if whether or not you're doing k-nearest neighbors, and here's all of the data in the data set, would be as part of this little XML file. Or if you're doing a tree, it's going to define each node and tell you how to traverse through it. Or same with the support vector machine. All of that, and this model was this standard was just updated, I think, in January or February for 2014. And it's going to tell you how to put all of that together. If this is an ensemble classifier, it's going to define multiple classifiers, right, as subgroups in the XML. And then it's going to tell you how to combine all of those ensembles together. Right? What's an example of an ensemble classifier that we've talked about in class? What do I call it? If I train up a bunch of decision trees, a bunch of different ones, and then throw them all together into one classifier, what's that? A random forest. Bing. So that would be one method that you could use right here. Okay, good. However, even though that this PMML exists, there's really no standard machine learning library that exists for iOS and using PMML. And what that means is that even though there's a way to export all of these model parameters, there's only a few examples right now for how to load all of those parameters in and essentially use it for classification, right? That's not so great because it means you need to either find all of that code somewhere and transfer it over to iOS or write your own, right? So I did find one actually pretty good example that works on BigML's website, which essentially it allows you to load up a tree inside of the iOS format and use it for classification. Okay, and this is a budding standard. So it's only recently become kind of that you guys even need to know this information. It's only kind of recently developed in that way. And so for mobile developers, this is still kind of getting wrangled out. But my guess is that PMML is going to take over and it'll become not just the de facto standard, but it will become the standard for doing machine learning. and it'll be implemented iOS, Android, and across devices, right? Because it'll become more and more common. So a really, really quick example. This is what PMML might look like. It's your standard XML. You have an element name. It goes through, and it has all of the different mining sequence, all the different things that you can go through on this model. If you want to define, it also has a little thing for defining different matrix data. So if you had a matrix that was, I don't know, 5 by 5, and it had this data, this might be how you do it. You can also do it with a sparse matrix representation. Have we ever seen this before in class when we were doing the OpenCV lecture? Yes, partly. Have we ever seen the machine learning, this machine learning side though? Like something that was, have we ever loaded up a classifier from an XML?
Yes, face detection.
Face detection. You remember when we loaded up those HAR cascades filters and did face detection on OpenCV? All of those were .xml extensions, right? They looked like this. They're essentially like this was a tree that it classified, and it had the different like features and recs and which way you go. All of that was stuff we used in that HAR cascade filter. So yeah, we've been kind of using it already. This is not, by the way, in standard PMML format. It's in XML format, OpenCV XML format. But there's some talk in the OpenCV community about actually switching things over to PMML. So we'll see if that happens. Is there any disadvantages to using PMML? It's ASCII text. Size. Yeah. Essentially, it's really good for being portable. But once you get a lot of data, that's a lot of parameters that are inside of your model, this XML file gets bigger and bigger and bigger and bigger and bigger. So it's something to keep in mind. Okay. So if we get through the demos today, I'm going to say that there's no class Wednesday. Okay? So if we get through all of the demos today, essentially what Wednesday next time will be is an extended lab period for everybody. I will be here. I will sit in this lab, and it will be this huge, long lab period where we will sit down and I will go over everything that you want for the proposal, everything that you want to try and turn in the lab assignment that is due this week. Why am I doing this? Because I graded A4 and A5, and you guys are doing pretty well in this class. And it's obvious that you guys are putting a lot of effort into it, and I feel like I'm taking up a lot of time. Okay? So I want to make sure that everybody is on a good roadmap and that you're moving forward to be able to put the final project together. So next time it'll be essentially like a flipped classroom, right? Where it'll be extended lab period is really what it'll be. Okay? So keep in mind the final project, take it real seriously and do not wait to start it. Okay? It is worth an unbelievable amount in this class. Okay? It's 40% of your grade. All right? So put some effort into it. Have fun with it. If you have fun with it, you're going to be fine. Okay? And demo day is going to come around, and I think you're going to have something very cool. Okay? And then you can take it out of this class and sell it, hopefully. That may not be true.
I was going to say SMU.
SMU.
SMU has rights to anything that you make, right? And what they mean by that is that they may actually incubate you as a startup, right? If SMU passes on it, and as long as you've given them the option, say, hey, we have this idea, that's still yours, okay? So when you're putting something together for a company, people just want to know that your intellectual property is defensible. So if you're going out and you're looking for startup money, and you've said, hey, SMU has already passed on this idea, then you have complete all of the rights to file your own patent if you wanted to. Okay? Do not post your source code publicly. All right? That's very important if you want to take something beyond this class. Okay? You can talk about it on the web, and that's fine. But don't post the source code. Okay? Or if you do, just know the repercussions of that. Okay, so before I go into all of this demo, what are you guys working on for A6? What kind of data? Somebody tell me what data you're working on. I know what you guys are doing. You're going to be up, what? Okay, you guys are uploading accelerometer data, right? What kind of accelerometer data? What I mean by that is, are you pre-processing it in any way? Are you like looking at windows?
Taking like the 1 second sample, like 100 samples in 1 second, and using the X as the axis.
Okay. So you got like 200 data points, and you're going to upload them as feature data. Okay. You guys are uploading feature data for essentially step counting, right? But it's more than step count. It's predictive step counting. What else?
So we upload accelerometer and gyroscope data.
Mhm.
But before we send the raw data in, we do some like separate the pin, a second each pin for 5 seconds, so that we can reduce the noise and stuff, and then we put those as a packet to the server chain.
Okay, so you're doing a little bit of summary statistics, essentially,
Like that.
on some of the data, and then uploading those as features.
Right.
Okay. What did you guys end up doing? Or
Audio data,
Mhm.
note detector,
Predictive
predictive note detector.
note detection.
The sample would be, you play A, it listens to it, so we play A, next time we should be able to predict this in A.
Gotcha. Perfect. So you're uploading what, FFT data? Okay.
Will be.
Yeah. Fair enough. Fair enough. Does anybody else know what they're doing? What kind of data? Does anybody have any different data types than what we're talking about here? Most of what we have right now are just these continuous feature data points, right? And that's good because that'll fit my example. Is there anything else? All right. Cool. So that sounds good. So you guys are doing gestures, notes, predictive analytics. I think this is looking good. Okay. So has everyone been able to install the server and run it on their? Yes. Right? Thank you, Gavin, and the internet, for this right here. I sent this out to a lot of different groups. I just did it from my phone, so I was kind of like I was like looking around the lab essentially last Wednesday and like, oh, okay, I need to send it to you, I need to send it to you. Has anybody not been able to install Tornado? Anything like that? Good, all right, yeah, excellent. Okay, so the first thing I'm gonna do is give you a generic example of just uploading data so that we can go through some of the URLs and stuff that are there that exist in the Python code and iOS. After that, instead of just uploading random data, what we're going to do is Corner Tapper. I'm going to create an app. Well, it's already been created, but I'm going to go over it. And it's going to be called Corner Tapper. And essentially, it looks like this. What I'm going to do is I'm going to take the phone, and I'm going to tap it right here. Right? And it's going to tell me whether or not I'm tapping in the 1, the 0 position, the 3 position, or the 2 position. Right? And all I'm going to do is I'm going to upload raw accelerometer data. And all of the examples, I'm going to offload all of the work to my machine learning algorithm. Right? I'm just going to upload raw accelerometer data and see if it can start telling the difference between 0s, 1s, 2s, and 3s, where that's the different modes of operation. Okay? Good? Okay. Is this an important application? Somebody's like, no.
By itself, no. But you could use this
By itself,
information to maybe learn something.
you could use this information to maybe learn something. I like that. This is good. This is good. This is good. Does anyone know someone that's blind? No. Does anyone know how people interact with a mobile Braille system? No? So this is an application called Braille Touch. Normally the way that you interact with mobile Braille examples is you have 6 different positions that you use. And you can tap through and also get some feedback by vibration underneath. It's kind of the digital equivalent of Braille, right? And you're able to kind of put all these dots together. Braille Touch is something that's on the App Store where essentially you can actually go through and tap the different parts of the phone. And it turns it into a mobile Braille example, right, where you can have these different taps, right? So you can, so essentially you install this, and all of a sudden now you can do text messaging, right, because you can't see the keyboard, right? Or maybe you don't want to talk into your phone, right, which is kind of an invasion of privacy most of the time when you're putting text together, right? I don't want to send a text via voice. I just don't want to do it. Why? Because it's my text message, You don't. It doesn't matter why. It's mine. Right. I would have called someone and talked about it openly if I wanted to send it. How do you open the application? There's accessibility things that you can do with like clicking through, and if you run it in the background as a service, iOS is pretty good about opening up some of the accessibility things that you can do with that. Yeah? So the makers of Braille Touch, I don't know if I should tell this story. Yeah, I should.
That means yes.
So when I was a graduate student, I sat next to this wonderful girl, and she was working on assistive technology, right? And she kind of came to me one day, and she talked to me about this idea of tapping on the back of the phone and seeing if it would actually work. And I said, that's a great idea. I would love to help you out on it if you ever get to that. And she's like, well, maybe I will. Well, she went over to Georgia Tech, and she talked. She actually gave this as an example of some of the things that she was going to work on. And 4 months later, there were 2 guys at Georgia Tech that published a paper and then created this application and put it on the App Store. And it's kind of a little weird how it came about from that fashion. So essentially, they took this from her and decided that they were going to make it. So I think that kind of fits back into what we're talking about here is protect your IP. Okay? If you have an idea, it's great to talk about it, but maybe not in a public forum. Talk about it with someone you know. Okay? Does that make sense? All right. Let's do this. Okay. So the first thing that we're going to do is this HTTP example. Open up. Here we go. Is that big enough? Okay, good. So this HTTP example is essentially the same example that we had before. You know what? Let me make sure that... Let's make sure that we're here. Voila. Okay. We've got their application. So essentially, one of the things, the first thing we've got is a pound define for the server URL up top. Okay? So this is running for Eric's MacBook Pro.local on port 8000. Right? Where will this work? That means I'm going to connect to the server here. Where is this going to work? When will this work? When I'm on the same subnet. Yeah. Right? Now, Gavin, you keep telling me that I have an IP address. Let's talk about that, though. You were on the Wi-Fi? Well, good for you. So apparently it will work. Okay. Yeah, everyone keeps telling me that. Everyone keeps telling me that.
It's one of the things where they were one of the first schools to have like all campus Wi-Fi back in like '98, and then a lot of that.
So you should. So you should be able to like hook your Mac Mini up, as long as it's running on PerunaNet. It will have a public-facing IP that you can put right here as your public face. Do not forget HTTP : / Why? It'll crash. Why will it crash? If you put it twice, it doesn't like that either. That's true. Yes, it does not assume that you mean HTTP if you don't put it. It assumes that you mean whatever you put there. So if you were to put FTP or SCP or whatever you want to put there, that's what it's going to assume the protocol is. So put HTTP. All right. So this application will do a couple of things. Let's look at the storyboard here. The storyboard here looks like this. We did all of this stuff at the top, I don't know, a couple of weeks ago. send post JSON, send get request. Down here, there's this function called add labeled data, get dataset ID, make model, predict 1. Okay, add labeled data. What does that do? Gonna add some labeled data. Okay, good. Glad you're coming with me on that one. Let's go over here to, what is it, send post array? All right. So this is what it's going to do. It's going to create some data right here. Data is a random number times 10. Okay? It's some random number times 10. Then I'm going to create this NS dictionary of features, labels, and a dataset ID. Okay? Those features are going to be that random number times another random number, and that random number squared. Okay? That's the feature data. The label is going to be the integer value of data. Okay? So what does this mean? Not much. It's an example of, like, I'm going to take a number at random. I'm going to take the floor of it and say that's the label. And I'm going to see if my machine learning algorithm can figure out what I'm doing as a floor operation on my data. Right? Okay? Good? Not good? Okay. All right, so I'm going to take this NS dictionary, I'm going to make it into an NS data, right? And then I'm going to upload it as a post request. All right, so I'm uploading data into my server, right? And I am uploading it into the URL where I have my server URL right here, and then add data point. Okay, so whatever handler I have for add data point is going to take these features and labels data and put it into the database. All right, so that seems easy enough. What next? Get dataset ID. I have a base URL, which is get new dataset ID. What do you think that does? You don't have to answer that. So essentially what I put together here is a get request. Why would I use a get request here? Because I'm getting something? Yeah. Yeah. It really is that simple. Because I'm requesting something from the server. Right? And so what I'm going to get back is right here. Right? So inside of my completion handler, whenever this task completes, I'm going to take my response data, I'm going to deserialize it. Right? What I get back is bytes. I'm going to deserialize that, and I'm going to save self.dsid for the response data that I get back at the DSID. Okay? And I'm not performing any error checking here. That's bad. But we're going to assume that what we get back is what we wanted. Okay. Then I've got this other thing, which is update model. Right? So I'm going to put together a GET request where the query is I'm going to the base URL and then at the update model extension. Then I'm going to say DSID equals the DSID that I have. Right? So that's the dataset ID. So I'm going to create a model when DSID equals this. Yeah? Okay. So I'm essentially, so my application is telling the server to create that new model. Okay? Now, what I get back here, I get a response back. And I deserialize it, and then response data at the resub accuracy, and I print that out. I print that value. Okay? So essentially, I'm going to go up to I'm going to say I'm going to upload all of this data, and I'm going to tell the web server to create a new model, and what it's going to send back to me is the accuracy of that model based on the data that I gave it. Okay? It's not going to cross-validate that. It's going to give me resubstitution. You guys remember what resubstitution is? Yes. I'm going to train the data with, I'm going to train the model with the same data that I'm testing on, and it's going to tell me how good it did. Okay? That's what it's going to do. Okay. What is this predict feature thing? What is that? Well, I'm going to go through. I'm going to create the exact same thing that I did before, right? Like whenever I hit that button, which is essentially predict 1, what I'm going to do is I'm going to make a feature, and that feature is going to be the exact same thing that I had before, right? Where I have random data times more random data, and random data squared. Okay? Then I'm going to tell it the data set ID that I want it to predict from. All right, so it's going to predict from it. And it's going to come down here and it's going to do a post task, right? It's going to do a post request where the response data that I get back is going to be prediction, right? So if I go in here and I get response data at the prediction value, that'll be the response. Okay? And then the label that it should be is the floored value, int data, right? Right, so what this is going to print out is it's going to print out the actual label that it was, and it's going to put out the prediction from my model. Okay? Happiness? Okay, so let's run it. Let's see what this does. Play. Build succeeded. Okay, so I'm going to get a dataset ID. And the new dataset ID is null. Why? My server's not running. God, what am I doing? So, hey, I'm going to run MongoDB. How do I do that with this? Has anyone not run MongoDB yet? Cool. All right, I'm running it. It's listening on localhost ports. Now I'm going to run Tornado. Right, so I'm inside of this Tornado running. What I'm running is tornado underscore scikit-learn.py. Yeah? Okay, it's running. So now, when I add some labeled data, it's going to freak out. Wow, what just happened? Ah, I got null for dataset ID. That's exactly right. Let's run it again. Just ignore that. What should I be doing? Error checking? Yeah, should. All right, so now if I run get dataset ID, oh, okay, hey, the new dataset ID is 7. Okay, so I'm going to add some labeled data. Right? Add data point. I've got 1 data point in my model now. I'm going to add some labeled data again. I've got 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 data points. Should I create a model from 10 data points? Why not? It's so few data points. Let's try it. Make a model. I just clicked make a model. All right, so update model for dataset ID equals 7. Wonderful. Let's see what I got back. It says accuracy using resubstitution is 70%. 0.7. So 70% of the data was classified correctly. All right, now if I do a predict 1, all right, I just clicked predict 1. Bam. You can see that I did post request for predict 1. What it came back with, the actual label was 2. The prediction was 3. Not bad. What if I do it again? Predict 1. Actual label 2, prediction 3. Predict 1. Actual label was 4, the prediction was 3. Is it going to predict anything other than 3? Actual label was 9, prediction was 6. Not so great. What can I do? More data. Let's crazy. I have no idea how much labeled data I just added. A lot. Someone can count that. I'm not going to do it. Let's just keep it. Wonderful. All right, sweet. Now let's make a model. Made a model. Resubstitution accuracy is 0.9038. All right, 90%. All right, sweet. Let's predict 1. See what comes back. Actual label 5, prediction 6. Okay, well, that's fair enough. That could happen, right? Predict 1, actual label 3, prediction 3. 1, 1. 0, 0. 4, 3. 22 00 44. Wow, it's getting a lot better. Okay, so I can add a lot more data into my server and figure things out. What's going on the server side? Let's figure it out. I don't have it open. Fine. Okay, what I'm going to do is open up the tornado scikit-learn.py in Xcode, apparently. That's fine. And then the sklearn handlers. We're going to open up both of those. Okay. So essentially, this just defines all of the handlers that we have. Remember, we have the get new dataset ID, which is request new dataset, update model, and then predict one. All right, so let's take a look at those. Okay. So request new dataset ID. What happens here? I say A equals self.db.labeled instances.find1 sort dataset ID -1. What does that line of code do? Does anybody know? Yeah, it gets the highest dataset ID that I have in my database. Then I say new session ID is equal to float value, add 1, and then self.write.json and send it back. All right, that's my new dataset ID. So I went from 6 to 7. Awesome. Great. Update model for dataset ID. All right, so I get the dataset ID as a get from here. Then what I do is I go through for A in self.labeledinstances.find the DSID. So anywhere where DSID is equal to what was sent up, I'm going to put together a matrix of feature values. And I'm going to make sure that they're all float numbers. And then I'm going to go grab all of the labels for that dataset ID. And then I'm going to use scikit-learn. And I'm going to say, hey, k nearest neighbors classifier with the 3 neighbors, the 3 nearest neighbors. And then I'm going to go through and I'm going to fit that classifier. I'm going to predict the output of that classifier, right? So based on, so here's the data is F, here's the labels L, and then I'm going to predict based on F. So that'll be L star versus L. The accuracy is going to be the sum of the times that L star equals L divided by the length, right? That's my accuracy. Then I'm going to put it in the database, which essentially means I'm going to pickle it. What is that? I'm essentially binarizing it, right? So I'm going to essentially make it into bytes. I'm going to store those bytes inside of this thing called model. And then I'm going to write back down the resub accuracy, which we saw before. Yeah? Okay, now predict 1 from the data set. Somebody tell me what this line of code does. Yes, absolutely. So JSON.loadS, right? So it's going to go through this and it's going to deserialize all the features that were sent up so that data now has a feature and a dataset ID as part of the dictionary, right? So then I'm going to get the feature values as floats. And then I'm going to go in here and I'm going to say find 1 model for the given dataset ID that I have. I'm going to unpickle it. And I'm going to call c2.predict the feature values. And I'm going to get a predicted label, and I'm going to send it back down. Is this a good implementation? What's that? Besides no error checking. It's not bad. What would make this better? What if that model that it's loading up is pretty big? What if it takes a half a second to load it up?
We need to block.
It's going to block the thread. It's going to block the tornado I/O loop. So, extra credit is given to anyone who can write essentially the training and this code in Tornado without blocking the I/O loop. That's one of the extra credit assignments. You do not have to do that, but it is 1 point extra credit. Okay? And when I say that, I mean, I'm literally talking about, like, you can spawn separate threads, you can do whatever you need to do for it, just as long as you're not blocking the Tornado I/O loop. If those other threads that get spawned take the number of concurrent connections you can have down, that's fine. That's not what I'm saying right here, because that's just a limitation of the computing power of your server. Okay? All right. So now, let's do something meaningful. And what I mean by that is let's do something with another project. I just closed that. I didn't mean to do, well, it's fine. All right, so now I'm going to go over to this. Another Xcode project. Let me connect back to the server here. There. All right. So what we have right here is the app that I gave you, essentially, right? And I've already pre-trained one of the models for dataset ID 6. Okay? I am going to keep the MongoDB and Tornado running because it works the exact same way. So what I'm going to do here is essentially, I'm going to go through a calibration protocol. So there's this button called Calibrate Once. Let's see what Calibrate Once does. Okay, so essentially, let's go over the app really, really quickly. There's two functions at the very top. One of them are 2 pound defines. One is the server URL, and one is update interval. Okay? Update interval I have set to be 1/10. All right? That means I'm going to be sampling from the accelerometer 10 times per second. That's the way that this application works. Right? And so there's a lot of stuff that gets done here, things we've talked about before. We're going to store the accelerometer updates, right? So I've got a CM motion manager. I've got this ring buffer right here. I'm going to save things into a ring buffer, which is right there. You'll notice that this ring buffer, man, that's weird. It's not a C++ implementation. It's an Objective-C implementation. How did I do that? I wrote it. It wasn't that hard, all right? Right, so you can go in here to this ring buffer, and the public API is get data as vector and add new data. Right, so add new data has X data, Y data, and Z. Right? You can check out that implementation if you want. So essentially, in viewDidLoad, I'm going to set up some of my initial values, like I'm not calibrating, I'm not waiting for any input data. Calibration stage is -1. Man, what would I use a calibration stage for? If you're calibrating, right? Depends on which tap you're trying to calibrate, right? So calibration stage 0 is going to be when I'm tapping this corner. Calibration stage 1, 2, 3, just like I have it labeled, all right? Then I'm going to configure the NSURL session and start it. And then I'm going to configure my acceleration updates. Right? So I've got my self.cm motion manager, start device motion updates to queue. I've got some background queue that I'm running on that I'm going to be adding these to. And then essentially I'm just going to go in and I'm going to add the X, Y, and Z to the ring buffer. Right? So I'm just calling ring buffer, add new data, X, Y, and Z. Then what I'm going to do is I'm going to take the magnitude of that X, Y, and Z data, the current data that I have, and I'm going to say, okay, if the magnitude is greater than self.magnitude value, some value, right? If there's enough acceleration, add operation with block, motion event occurred. All right, so what is motion event occurred? If there was enough acceleration, I want to query the server. I want to say, hey, what was that motion? Okay? All right, so let's just go over here. Motion event occurred. It's right here. So if we're calibrating, then I'm going to get the current calibration stage, and I'm going to send up the ring buffer, all of the data in the ring buffer, right? It's just this moving window of all of the acceleration for the past second. So I'm going to send the past second, which would be how many samples? 10. 10 samples, right? How long would that vector be? 30. 10 samples, one for X, Y, and Z. All right, so I'm going to have 30 features. Right, I'm just going to send those in, send feature day array, with label whatever the calibration stage is. Okay, so I'm going to send up that data, and then I'm going to assume that we go to the next calibration stage. Right, so once I click that get one example, it assumes that I go through 0, 1, 2, 3, and I give it an example of all 4 corners of a tapping. Okay, that's only if I'm calibrating. If I'm not calibrating, let's make sure that I'm waiting for input data. And then I'm going to do the same thing. I'm going to say predict feature, which is another function. But essentially all I'm doing is grabbing the data from the ring buffer for the past second, and I'm going to try and get a classification for it. Okay? Sound good? Should we try it? Let's run it. See how we'll see how well or how badly it works. All right, so you can see it's got a lot of like false positives. I'm just moving it around, right? I'm not tapping anything, right? There's this little slider button, which essentially is telling it how often, what the magnitude of the acceleration needs to be for it to try and request data from the server. Okay, so now, well, I just barely clicked. Let me put that a little higher. So now, so let me try and click the 1. We'll see if this works. Ah, didn't get it. Let me click the 1 again. Hey, got it. I think I've set this a little too high. I just clicked the 2, by the way. I really did. Let me click the 3. Ah, I got the 1 and the 3. Why did it get the 1 and the 3? Yeah, it's because I'm clicking the 3, and essentially, like right after I do that, it's a natural motion that I'm trying to push back down, right? So I'm clicking the 3, and then it also clicks the 1, right? So it's not perfect, but it's not bad. Should we add some more data? Okay, so I'm going to click calibrate once. When I hit calibrate once, the first thing it's going to do is light up the little 0. Okay? Then I'm going to click on that. The second that I've gotten an example from that, it's going to go to the 1, it's going to go to the 2, it's going to go to the 3. So it's going to visually guide me through the calibration process. All right, so calibrate once. That's what 0 looks like. There's 1, whoops, 1, 1, 2, 3. Bam, I've added new data. Okay, I can keep doing that as many times as I want, as many examples as I want. Then I can click that make model button right there. Bam, make model. If you're looking over here, it says my resubstitution accuracy is 70%, down at the very, very bottom, which you can't see because it's falling off the screen. But now I can try some more things. It's not bad. It's probably about 70% accurate. We could create a whole new data set and see how it works also, right here in class. Just make it happen. Questions on this? This is essentially what I'm asking you to do for A6. Is create a calibration protocol for some data. query a server, have it send back down. Machine learning as a service. We got through the demos with 10 minutes left. 20 minutes left. 20 minutes left. Pretty awesome. Question?
So you specify the threshold, the magnitude of the threshold, right?
Uh-huh.
It means that the number of thresholds will affect the model of what
It
you
will.
train.
It will.
So it means that we can not just like manually doing that if we don't have the data in the server. And like if you train threshold 1 and you test threshold 5, maybe the result is not like it's matched. You know what I mean?
That's a possibility. It's a possibility. As long as I give it enough data, it should be okay, though. Because all that is a segmentation threshold, right? It's how often am I requesting data, right? So it's really just like, when am I going to send to the server, right? So as long as it's above a certain acceleration, that means something happened, right? So the segmentation is separate than the classification. Like, once I know that something has happened and I send that data up, then I can form the classification on it. Right? When I have a false positive, it's nothing is going on, but I'm still trying to classify on it. And the only examples it has, the only thing it knows in the world is 0, 1, 2, and 3. It doesn't know not a feature or like not a tap. Right? I haven't given that. Right?
So when you tap, like when you do strong tap on it,
Mhm.
the value you get is going to be higher number, right?
Yeah.
And then if you have a high threshold, the information on the server is going to be a lot of high number in there. And when you train it, it's the model expects the high numbers in it instead of any other number.
That's correct. That is
So
correct.
if is that the case, what if we somehow normalize it and send the server? Is that going to have a big difference on the model?
Yes.
Okay.
Probably a good positive influence on it. The way that you would do that is through a scale transform, which I would use scikit-learn for.
Okay.
Now the only kind of caveat there is you will need to save the scaling transformation as a separate model inside of your MongoDB, right? So you'd create another collection, or you could save it as part of the model, right? So you'd have a model, and then also with that model as part of the document would be a scaler. And you could just pickle it and save that as well. And then when you unload it, you could run that as a transformation and then run the data. Did that come out right? Do you know what I'm saying?
50%.
Essentially, if you look back at the example, some of the example code that was for just using scikit-learn, oh, it's in here. There is a so there's this preprocessing.scale of feature data. That is essentially learning from the feature data what the dynamic range is. Right? And so when I run preprocessing.scale right here, I would want to save that class. I would want to create a vector equals preprocessing.scale and then vector.fit the data. I would want to save that class vector. And then when I depickle everything, or unpickle is the Pythonic way, I would want to run the preprocessing and then do the classification.
Do we need to save the scale for that?
Mm-hmm. Or you can just save it, right? Like you could just scale everything manually if you wanted to.
Okay.
But the advantage of doing it this way is you could do PCA and not even know what PCA is. You could just run it. And it would save everything. Questions, comments, concerns? Do you guys know how to do A6? Did you know how to do A6 before? No? Okay. Well, hopefully this is clearer, right? What A6 is, what I'm asking for. That's it. That's all I got. Hey. 1. 2. Nice. Yep, that's 70%. All right, I will post all of this code on Blackboard. At least the new HTTP example. It's not bad.
I love how there's like, I don't know if it's like the gyroscope swinging back.